In this video we'll look at PQ based HDR, ST2084, which as an absolute standard is somewhat different to working with the likes of Rec 709. To start with, we've profiled an HDR display, in this case an Asus professional display, and we've done a large grey only profile rather than a full volumetric one, just for time. And if we have a look at that, and at the minute we're comparing it to Rec 709, but we're doing that deliberately as the pre-calibrated display is using a power law gamma, which we can then apply the PQ EOTF to. And we can see that the peak luminance of the display is just over 1300 nits and a low of 0.0044 nits. And again, if we look at the actual manual measure, we can see again the peak value there. And we also have a colour temperature offset, which we can see if we look at the RGB balance, being that green is higher than blue, and blue is slightly higher than the target, while red is significantly lower. Now that obviously means that when we calibrate, we're going to have to reduce the peak luminance of the display slightly to compensate for that inaccurate colour temperature. So the first thing that we'll do is generate a new ST2084 colour space that targets the peak luminance of this display reduced slightly to allow for that colour temperature shift. So if we go into our Manage Spaces library again, but this time into our colour spaces, now we're going to do a grading display to start with, which means we're going to target P3D65 rather than Rec 2020. And we'll start by modifying the existing colour space, which obviously initially targets 10,000 nits as the peak value for PQ HDR, the ST2084 standard. And rather than targeting the maximum the display has, we're going to target a fixed value to make what is a standard colour space for PQ, and we're going to target 1200 nits. And we will just add that into the name so we can find it in the library. And now in our colour spaces user we have our new colour space, and if we now use that as our target in the graphs, we can see that the power law of the display as profiled versus the actual EOTF that we're going to be targeting when calibrating this display. So now we will open our LUT tools and we will set the source to be our newly generated colour space. We've already got in there the Asus grey large profile as our destination. At the moment it's picked up on the maximum nits of the display, but because PQ is an absolute standard, we need that to match the standard of our target colour space. The reason for it being variable is it can actually be useful in changing the EOTF for situations where the viewing environment is less than ideal. This does obviously break the PQ standard, but it can be very useful to generate a better viewing image in kind of home use situations where the light cannot be controlled. We'll call that Asus grading 1200 and use peak chroma. We will use gamut mapping and we will create the LUT. While that's generating the LUT, we do have this information freely available in the colour space user manual of the website, which is under the colour space guides here. And if you go to the library, go to modify, then you can see the different colour spaces, camera options and so on. And if we click ST2084, there we have information on how to use the ST2084 menu. We also have in the LUT tools information on the using the destination and source, but also on St2084 Hdr and about using the limit max luminance. Cup of tea while that's going on. And there we go. LUT complete, and if we look at the graph here, we can see in the 3D view the reduction in the peak luminance overall and the general gamut reduction from the native gamut of the display to that of P3D65. And in the 1D graph we can see that we are clipping at our 1200 nits, and we can see that we are just within the available luminance of the display because we are just slightly below the peak red that the display can actually generate. But if we are looking to generate a calibration for a home TV, we would be using Rec 2020, and again we'll modify to the same 1200 nits, but because this is going to be for home viewing, we will want to either use soft roll-off or tone mapping so that we don't have a harsh clip, assuming that the mastering display that was used to generate the footage that we're going to view was of a greater peak nits value than the display we're calibrating. So if we assume that the display used for mastering had a peak of 2000 nits, we can use our target profile to set initially our min and max levels so we know what the overall maximum available luminance is pre-calibration, obviously with the color temperature variation. So again, we'll bring that down to 1200 nits as we know that that works, and this time we will call this TV 1200 nits. And we're going to use YRGB as the tone mapping option. Dependent on your preference, you have the various choices here, or obviously the use of soft roll-off, which gives you more variation because you can actually set the point at which the roll-off starts. So you can actually increase the softening effect of the roll-off compared to the fixed values of tone mapping. But we'll use tone mapping in this instance, and we will save. And now if we go back to our profile graph and we select the TV, we can now see that we have roll-off built into the highlights of the PQ EOTF. And again, generating the lookup table, we will select our Rec 2020 TV, and again let's change that to TV so we know we are. We again want to be targeting the same max as the color space standard that we have made. The reason for this being variable is that you can use it to change the EOTF, as was said earlier, so that we can actually compensate for viewing environments that are less than perfect. And we'll come back to that because it can be a useful tool in a moment. But for now, we will generate that LUT. Obviously this time the gamut conversion is less because we're targeting Rec 2020. But again, here we can see the generated LUT, and if we look at our 1D graph, we can now see that there is roll-off in the highlights compared to the hard clipping of the grading LUT. While we're here, we're talking about the max luminance here. If we change that, let's say 1000, and generate another LUT, complete, and what we now have is an EOTF based on exactly the same information, but you can see what's happened is that because the max value is less than the actual color space, it's reduced the EOTF. And if we went the other way, it would increase it. Now, reducing it doesn't really help because it will make the end image darker. But if we go the other way, and we'll just select our TV 1200 and we're going to remodify it. So what we're going to do this time is target a lesser value. So let's, rather than targeting 1200, let's say target, oh, I don't know, 500 nits. And we'll change that here. Save that. And we'll now set that as our target. But we will leave our actual max at 1200. So the colour space we're aiming for is 500 nits peak, but we're going to actually set to 1200 nits because that's the max the display can do. And if we create this LUT, and we'll change the name and create this LUT, LUT generation complete. And if we now look at the 1D graph for this particular LUT and compare it to the equivalent 1200, you can see the difference in the EOTF. So this means that this LUT will calibrate a display, a home TV, to be brighter, even though the PQ standard theoretically doesn't allow for that. So it's a very useful capability to overcome one of the bigger issues of PQ HDR, in that its absolute standard can mean that the images are very dark in less than ideal viewing conditions. And the last thing we'll look at is the multiplier. Now, multipliers are used when the display that you're working with can't reach the actual peak value that is required for HDR, so say 1000 nits, which obviously projectors tend to be where they're applicable. So if we look at a standard Rec 709 profile, we can see that here, this is a pure Rec 709, so it's synthetic, but it's 100 nits peak. Well, obviously that's not suitable for watching HDR footage as is if we apply the actual PQ standard by default. So this time when we go into our colour space, and again Rec 2020 because it's for a home TV viewing, so the source material will be Rec 2020. But this time when we select our target profile, and this time when we update, you can see that obviously we're now targeting a max of 100 nits. And if we say again that our source material was 2000 nits, that's going to give us a useless end profile. So what we'll do instead is we'll add a multiplier, and we'll use a value of 10 in this instance. Now you can see that it's now changed the effective nits to just 10 nits because we're presently working with 100 nits. But if we now re-update, we can see that it now says, well, there's a multiplier of 10 being applied, so the display theoretically is 1000 nits because of the multiplier, even though the actual effective nits of the display is only 100. So we'll just call this projector and save that. And again, when we compare here, we can see that we are comparing the original 100 nits to the EOTF scaled for that effective nits. And if we go back in and generate a new lookup table, so selecting our projector as our new target color space and our 100 nit profile, and this time because we are using a multiplier and the projector color space is based on the effective nits of 100, we need to leave the maximum at 100 this time rather than the 1000 that we're theoretically targeting. And we'll call this projector 100 PQ and create. And there we are. And when we look at the profile this time, you can see that we have a EOTF, PQ EOTF, that is basically for a 1000 nit display, but will be applicable to our projector of just 100 nits because we are using the multiplier